An introduction to conditional probability. Conditional probability is the probability of an event occurring based upon a prior event occurring. In reality, this is typically what most probabilities are. For example, if a student is enrolled at Helena College, then that affects the likelihood that they're actually taking a class at Helena College. And if they're taking a class at Helena College, that affects if they're going to have a passing grade or not. So my example here is, what is the probability of passing Psych 100 is based upon the event of being enrolled in the course. And that depends also on the other events of being enrolled at Helena College and having attended the classes and all sorts of things. So probabilities are not always simple black and white. Like when you roll a dice, you know you only have 1 out of 6 chances and each number has an equal likely chance of occurring. In life, it's usually more complex than that. So the notation that we need to encounter today has to do with given situations. And here we have a formula. And the way that we read this left-hand side is the probability event E will occur when, that vertical line can be called when, event F occurs first. I also like to read this as the probability of E given F. So whichever way you feel comfortable with. The calculation for the probability of E occurring when event F occurs is equal to the numerator of the probability E intersect F divided by the probability of F. And notice this denominator that we're dividing by happens to match the given situation. This same formula can be simplified down if you happen to know that you're dealing with outcomes of a particular set having an equal chance of occurring. Then you could say that the probability of E given F is equal to the number in the intersection of E and F divided by the number in F. Okay, that same formula can be modified if you wanted to. Let's say you knew the given situation and you knew the probability of F, but you didn't know this intersection for some unique situation. Remember, you could adapt this equation and use it by plugging your numbers in for probability of E given F, and then the number for probability of F, multiply across, and you've got the probability of the intersection. Okay, let's move on to the example. It says, suppose a family has 2 children, and the youngest is a girl. What is the probability that both children are girls? So the problem on the left-hand side is that you want to know the probability that both are girls given the youngest child, or the second child, is a girl. So we have to think about this intersection. The intersection is the probability of both being girls intersecting with the youngest being a girl. Okay, and that intersection happens to be the situation that both have to be girls. The only way that both are girls and the youngest is a girl is if you have girl-girl. And thinking back to all the situations for how a couple could have 2 children, is that you could have girl-girl, boy-girl, girl-boy, or boy-boy. So we know the probability of having both being girls and also the youngest being a girl is 0.25. The denominator is the probability of the youngest being a girl. When we're focusing on the youngest being a girl, that's the second child, and we're only focusing on the second child. The second child could have been a girl or a boy. So being a girl is a 0.5 or a half chance. A 0.25 divided by 0.5 becomes 0.5 when you simplify it. So the probability of both being girls, given the youngest one is a girl, is 0.5. This problem could also be solved with a tree diagram. A tree diagram would say that we would have had 2 children born. Yes, 2 children being born. And this first layer of marks would say that the first child could have been a girl or a boy. and then the next layer could have been a girl or a boy. So we have the situation that we could have girl, 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 boy, boy, girl, or boy, boy. And we're looking for this situation of what's the probability both are girls given the youngest was a girl. And so we happen to be looking at this branch right here. And on that branch, we can see that there was a 0.5 chance of both of those being girls. Boys have a 0.5 chance all along here also. And if we were to have multiplied the branch of a girl and then a girl, multiply those probabilities, we're finding the probability of girl, girl being 0.25. And if we look back, the chance of the second one being a girl, and then we want to know what's the chance of this first one also as a girl, we could see that it was a 0.5, which matches our answer.